Bismillah. In this problem, the 50 kilogram crate is projected along the floor with an initial speed of 8 meter per second at when x is equal to 0. The coefficient of kinetic friction is given to us. It is 0.40. Calculate the time required t for the crate to come to rest, remember here, and the corresponding displacement or distance x traveled here. Okay, so let's see what information is given to us. If we see here, the mass of this box is given. It is 50 kilogram. Okay, and if you see, it is moving on a flat surface. There is a contact surface here. Okay, and of course we have kinetic friction values are given to us. It is 0.40 with an initial speed. So I can say the initial speed v naught is 8 meter per second. Okay, and it start from the position x. When it is 0, I will say x1, and we have to find x2. Okay, and time required to travel this distance. Okay, so before we solve, let's find what are the informations here and which concepts will be used. So if we see here, there is a mass is given and the kinematic friction coefficient is given. So most probably this question will be solved using the concept of F is equal to ma, or we can say this question is will use the concept of equation of the motion. So guys, let's start. When we have to use equation of motion, then in this case we have to make free body diagram. So let's draw a free body diagram for this picture. Okay guys, so in this case you can see that there is a mass. So as you know very well that mg will work downward direction, and of course there is a contact surface here on the bottom on the floor. So I will make a normal to the contact surface. So this is normal force which is always perpendicular to the contact surface. Okay, not normal to the body. Just remember, it is always normal to the contact surface. And so mu k is given here, so there will be friction force working against it. So in this case we can see that the motion as per this picture is given that velocity is in this direction. V naught is 8 meter per second. So as you know that friction force will work against it or opposite to the direction of the motion. So we can write the Fk, the friction force Fk is equal to mu k multiplied by normal force. Okay, so this is our Fk. Now we see there is no other force. We already made or draw all the forces working on it. Okay, so now we will solve or apply the Newton's second law. Okay, and as you know that Newton's second law, we write F is equal to ma in a simple term. Okay, so the next step, when we make free body diagram, we have to choose a suitable coordinate system. Now you can see that motion in this picture is in rectilinear direction, and you can say linear direction. Okay, so in this case we can use a simple x and y coordinate. Now question is that how we should apply x and y coordinate. See, can we use this type of x and y or this x and y? Okay, so best way to apply or use coordinate is choose the x in the direction of motion. So let's see here, I'm going to make x in this direction, okay, and then y in this direction. Okay, so I hope it is clear for you. I will write formula and I will calculate the component of forces in x and y direction. So I can write the fx is equal to max, and similarly I can write two components of this force may. Okay, now I will solve equation 1 and then I will solve equation 2. Okay, so let's go with the equation 1, fx is equal to max, and you know that this body is just moving in one direction, okay, in x direction. So I can say that ax is equal to a. Why? Because there is no direction acceleration in this y direction, so ay will be 0. So I can simply write fx. Okay, so let's draw all forces in, or let's calculate the forces working in x direction. So I see here that only fk is here, and fk is in negative direction, minus direction, because I took x plus in this direction and y plus in this direction. Okay, so I will write minus fk is equal to m and a. Okay, and a is not given to us. Okay, so this is, let's put the values here, fk, and as we know that fk is mu k n. Okay, is equal to mass of this body is given 50 kilogram multiplied by acceleration. So in this equation we can see, guys, how many unknowns are here. This is known to us, this is unknown n, and a acceleration is unknown. So let's solve equation number 2 of fy is equal to may. So here I will solve the second equation, fy is equal to may. This is my equation 2. Guys, if we see the picture, the free body diagram, we see that body is moving in x direction only. In y direction there is no motion, so acceleration ay is 0. Okay, so this is clear. So we can say that fy is equal to m multiplied by ay is 0, so I will write mafy is equal to 0. Let's see what are the forces working in y direction. So let's go back to the free body diagram, and here you see that there are two forces. One is normal force and another is mg, but both are in another direction. So if you see, n is moving upward, so it will be plus, and mg is going downward, so as per our coordinate selection it will be minus. So I can write n, which is moving upward direction, so I took is positive, minus mg, because mg was the direction of vector is downward, is equal to 0. Now in this equation, let's find what are the information given to us. So m is known, g is known, so we can write n is equal to mg, and m is 50 kilogram and ng is 9.81. So we got the value for n. This is our n. Okay, now we will go back to our equation 1, and in equation 1 you can see here, this is my equation 1, so I will bring it here and I will write minus mu k multiplied by n is equal to 50a. Okay, so I will put the values for the mu k, it is minus 0.4. Okay, multiplied by n 490.5 Newton is equal to 50 multiplied by a. So in this case, guys, we can easily calculate the acceleration a, that will be minus 3.92 meter per second square. Now, as you know that we have to calculate how far it goes and what will be time. So let me explain you again here. This is a block and it start from the position x1, which is 0, and it will move to the position to x2, okay, there will be some values, okay, and it will take time t to reach here. But at this moment, when it will reach at the x2 position, because of the friction factor, it will stop, okay. So when it will stop at x2, the velocity v2 will be 0, and v1 is already given to us. It is 8 meter per second. Guys, now we have acceleration, we have velocity, okay, and we need to calculate the displacement x and time t. So in this case, we can apply the uniform acceleration formula, or you can say the high school formula from the physics, which is if v2 square is equal to v1 square plus 2a and displacement, okay, this is displacement. So you can write this displacement here is v1 square plus 2a x2 minus x1, okay. So now I will put the values, because we know that v2 is already 0 here, okay. So I will put the values from v1, it is 8 square, and we already calculated acceleration. Just remember, it is minus 3.92, it is deceleration, okay, and the displacement x2, because x1 is 0, okay, this one is 0. So here from this equation we get the value of x2, and that is equal to 8.15 meter. Now let's move and calculate the time t. How we will calculate? Again, we will apply the very simple formula. V is equal to v naught plus at. So in this case, we have v2, we can modify this simple formula in our terms, v1 plus acceleration multiplied by time. So guys, here v2 is already 0 because it will stop at that point, and v1 is given to us. So let's solve this formula. I will write v2 is 0, v1 is 8 meter per second, and acceleration is minus 3.92 meter per second square, and time t. So here from this equation we can calculate time. It is 2.04 second. It means after it will reach in 2.04 second at x2 position, where the velocity will become 0, or the crate will stop there. Thank you very much. Have a nice time.